In this video, we're going to be looking at resultant vectors, also known as vector addition and subtraction. So what happens when we add and subtract vectors? Previously, when we looked at this, we had pictures with diagrams. So we could take an A and we could add on B. So we've got an A just there, line it up. And we add on B and we put it head to tail so the arrows are going following the journey round. We'd have A plus B and then we would get a resultant vector. So the final answer is the most direct route from beginning to end. So the final answer is the red arrow. So this red one is A plus B. The answer is the red one. Now, we've been looking at column vectors, so we can actually do this without drawing the diagrams if we want to. We can do it by saying, well, we're doing A plus B. Now this vector A, we can see is 1, 2, 3, 4, 5, 6, 1. So that's 6, 1. And we're adding onto it vector B, which is 2, negative 3. Now when we look at our answer here, we can say, well, our answer is 2, 4, 6, 8. And we've gone down 2, so negative 2. And if we look at how that's formed, you can see, oh, well, I've taken in all of the x component of the blue one plus the x component of the green one. So that's the x component of the blue, the x component of the green, I've added them together. And again here, you can see with the y's, I had one y, and then I took away 3, so I've got minus 2. So when we're looking at vector addition and subtraction, it's actually very straightforward. All we have to do is add or subtract, depending on what we're doing, our components. So let's have a look at what happens if we did A minus B. So here's our A. Now we want to take away B, which means that we want to go along B in the opposite direction. So it's going to go this way. And we would be doing A minus B. So our resultant vector would go from here to here. And you can see it's different to A plus B. So the resultant vector, A minus B. And then if we look at that in component form again, doing A minus B, we would have 6, 1, and we're going to take away 2, negative 3, and our answer is 2, 4 in the x direction. Oh, that's good, because that's the same as 6 minus 2. And then we're going to go 2, 4 up. And when we look at that closely, we can see, well, that's the same. 1 take away negative 3 gives us 4. We can do something even more complicated. So if we look at A minus B, we can take away C as well. So we've got A minus B and then we can even add on C. And it starts to get very complicated the more of these we add in, which means that being able to do it in component form is going to start having some benefits. So there's our beginning, there's our end. So this red one is now the vector A minus B plus C. Let's have a look at this in component form. So we have A minus B plus C, and let's pretend we haven't done this one above. So we're going to do the whole thing. So we would have 6, 1, minus 2, negative 3, then we're going to add on C. Well, C goes 4 along and 2 up. So it gives us 4, 2. So 6 minus 2 plus 4 gives us 8. Then 1, take away negative 3 is 4, plus the 2 gives us 6. Let's check and see that that component form meets what we saw and expect in the diagram. So it's looking at the red one is our resultant vector. So 2, 4, 6, 8. Yep. And from here, 2, 4, 6. Perfect. So that was these are the diagrams when we were drawing the vectors, and this is the addition done in component form. So in component form we can write this in general. If we have a vector A, B, and we add it on to CD, then we're going to get the resultant vector is A plus C, B plus D. And the same works for subtracting. If we have AB and we take away CD, then we're going to get the resultant vector A minus C, B minus D. So that's our general form. Next, we're going to look at some examples. So the example we're going to look at is this one. We're going to do 0, 3, and we're going to take away minus 1, 5. Sorry, let's start with addition actually. We'll add on minus 1, 5. So then, for our example, we're going to do all the working out so that we make sure we really understand what we're doing when we come back and look at this later. Okay. Now for your turn. Try this one. So our working out. Making sure we're extra careful with any negatives. And hopefully that's the answer you got. Let's try another example. This time we're going to do a subtraction. So we have 0, negative 3, take away minus 1, 5. You'll see that in the working out I put the negative 1 in a bracket just to make it clear and help me to remember to do take away -1. And doing those calculations, we get 1 -8. Now your turn. Try this question. Here's the working out, and hopefully that's the answer that you got as well. Let's see what you know now with some multiple choice questions. And this one, A, B, C or D. Question number 3, this one. And the last multiple choice question, this one. Finally, we have the 0 vector. Sometimes when we add or subtract, you can end up back where you started. So you could end up going in a big loop, or you could go there and come back. And so the resultant can sometimes be 0. This is called the 0 vector. And can be represented like this. So you could get it, so if you added on A to -A, then you get the 0 vector, because you'd have gone and then come back.